Hello, everyone. Thank you once again for joining me. My name is John Kayode Abisi, and my job, as I always say, sit at the intersection of product security and software engineering. So this is part 2 of my beginning video on product security. So this part 2, I want to kind of dedicate this into career development and roadmap in product security. And if you look at my slides, I want to just see what are the foundation. If you are just coming into product security, or you want to ramp up, or you want to pivot into product security, or you want to ramp up your knowledge, these are the things that you can leverage. Core topics that you need to cover is networking, your basic networking, your HTTPS, TLS architecture. Talk about Linux. We all know that Linux is very important. Authentication, cryptographic bases, APIs, databases, and software development lifecycle. So these are the topics you can cover. And moving away from that is that programming, be strong in programming language. Python is good, it's general purpose. JavaScript is mostly used for front end, and web applications form a very big part of product security engineering. Go or Java 2 is a good one. So I'm not here to recommend or to tell people what to do, but I'm just telling you based on experience what you can do to be successful in product security. Because I'm very sure that not every software engineer wants to pivot into product security. A lot of product security guys are coming from maybe IT operations. They are coming from maybe maybe some development background that might not be a core engineering, or maybe they do something like system administration in the past, DevOps and stuff like that, but they want to ramp up. So this information would be very, very useful for them. Then when you cover the phase 1, which is the foundation, which is the basis, then you move to phase 2, which is application security. Under this place, I know a lot of people that have been into penetration testing, bug bounty, can relate with this. So you have to learn injection, cross-site scripting, SSRF, IDOR, auth bypass, CSR. These are common vulnerabilities in web application. Maybe a web application, mobile applications. These are common vulnerabilities in those domains. So it's very important that when you are coming into these, if you are finding your footings, or you are pivoting into product security, or you maybe you just want to ramp up your knowledge, it's worth revisiting. Then you learn threat modeling. Highest return on skill. Threat modeling is very important, especially in the era of AI, because now a lot of products are built, by let me say citizen developers, people that are not maybe they are not engineers, software engineers. They just want to speak to frontier models and spin up a solution, or maybe an app. So now, and because AI is writing the code now, it's like we can't compete with AI in writing code. But one of the things that I know is that a lot of security best practices are ignored. A lot of secure way of doing things are ignored. So I think, based on experience and what I've seen in the market, one of the major skill that needs to be looked into right now is even being able to do threat modeling. Because if you have the transcript, or let me say your commands, your query, your vibe coding script, it can help a very good architecture, even the LLM itself, to build you an architecture. And if you have a kind of maybe a scaffolding architecture, you can feed that one into your threat modeling, toolings and your processes, and be able to move ahead with security function in that particular domain. So threat modeling is very important. Okay, so let's move forward. Then I move to, remember that what I'm doing in this video, in this episode, is more or less like how you handle your career as a product security engineer, what you can do, how you can pivot, how you can, those things you need to learn, where do you need to, put your effort. So that's what I'm doing. And product security engineering and cloud DevSecOps. I've been cloud DevSecOps. I have worked within DevOps team. I've worked within platform teams. I've worked within IT operation teams. I've worked within, engineering org itself. And it's very important for me to bring this. So when you do the first 2 phases, the 3 phase falls within the engineering and cloud environment. So now, secure engineering, this is where you do your CI/CD security, where you know how to embed security workflow, pipeline within your CI/CD pipeline, and where you do your SaaS DAST, dependency scanning, like your SNCC, SEMGREP, SC, we call it software component analysis, Secret scanning, this is where you scan if any engineer or developers have committed, API keys, password, database strings, connection strings, and all this kind of thing. Then you scan your, infrastructure as code, maybe your Terraform, your CloudFormation, and other the varieties of all those IAC tools, even your Ansible code, Ansible code. You want to scan them for, vulnerabilities, for secret, for configurations that doesn't meet best practices. Then you talk about your container security. This is where you look at your configuration. This is okay, the kind of privilege and access that the root user, maybe they're using root user or not, and how they handle maybe port exposure and stuff like that. You want to scan if maybe packages within the container image is vulnerable, maybe it's outdated, that's not been patched for very long, and suffer bill of material generation. So these are the things you do within the secure engineering. And like I've mentioned, these are the tools of trade. We have SameGrep there, Bobsuit, Snake, Trivy, Zap, CodeQL, GitHub Advanced Security. So you want to look that up. Then phase 4 is Cloud DevSecOps plus DevSecOps. So this is where you do AWS security, you do GCP security, you do Azure security. So I'm a multi-cloud guy, so I have to bring that to bear. So then Kubernetes, like I always say, identity and access management, secret management. These are the things you do within your cloud native environment. How is being done within AWS? How is it being done within Azure and GCP or even Oracle OCI? So all these things are very, very important for you to look at. But mind you just have to pick one, right? Like you just have to maybe start with one. Okay, like AWS. Maybe if you are running an Oracle shop, maybe Oracle OCI and stuff like that. Then I talk about the phase 5, which is product security leadership. So here you talk about this is what separates seniors, staff, or principal or architects. Now when you look at product security, most of the time, job role, they're asking for a principal level experience, they're asking for a staff level experience, they're asking for somebody who could do the core engineering work at the same time, help in architecting secure, software. So all these things, when you are moving to that, to that phase of your career, then you begin to look at security program designs, risk prioritization, security, metrics, developers enablement, AI security governance, compliance mapping, and stuff like that. It's always come to that, right? Like there must be that person who manage the kind of overall workflow, the person that guide the vision, that guide the effort, and make sure that we are actually delivering value, we are doing the right thing, and so that we are doing the right thing, that our effort is directed towards overall organizational strategy, and so that is understandable, and leadership handle that kind of thing. So if your career is towards that line, these are the things you have to begin to look into. Okay, so practices that will make you extremely successful. So one is learn to communicate with developers. I think that this is one of the most important things I've learned, in my career. Learn how to communicate with developers, because product security is more or less like a consulting arm of your company. Like you serve many orgs within the larger organization. Sometimes you can be helping, IT operations. Sometimes you might be helping platform or infrastructure or develop department or unit. Sometimes you might be helping maybe core development teams, on how to bring security into their workflow and how to ensure that that particular workflow is not like prevented from doing their job. So what I mean is that that communication is very important, and sometimes to be fair, it's not really like that. It's not an easy task. Like so communication must be clear, and both sides. So if you have a product team that is working with you, it should be a two-way thing. So it should be two-way things, right? So it shouldn't be just that the product team or the product engineer alone, talking. It should be well articulated from both ends. So the other one is think like a product engineer. Security teams fail when they don't understand delivery pressure, learn, agile, developers workflow, architectural review, performance trade-offs. Now, this is where it gets, sometimes scary. It's always like this silence, notion about security. Like security is like a gatekeeper that they kind of block, innovation, block, shipment, code shipping, and stuff like that. But it shouldn't be. And at the same time, the job of a security engineer or security team is to make sure that at the end of the day, you are shipping a well-secured, product. Now, if that is the case, security team fail when they don't understand delivery pressure. Now, my question about this is that when an idea or requirement and everything is coming to table, security should be part of the idea, should be part of the requirement, should be part of the pressure, should be part of the mandate in the first place. So that at the end of the day, you cannot make somebody outside of a decision or maybe a process, and all of a sudden you want that person to patch up. No, the communication should be from day one. As developers are getting the requirement and they're getting this thing, getting everything, the security should be aware of the pressure, so that at the end of the day, they can manage the pressure, alongside the workflow. Then they should be agile. Developers, they should be dynamic enough to know, okay, nothing stands for too long. Things are changing, requirements are changing, decisions are being made. So yeah, as long as security is part of that workflow, it becomes very easier. That is what I tell people. But when you have done everything and you want to kind of patch it down to security, it becomes a kind of oh, it's not, maybe they are not thinking like a product engineer. No, product security engineer should think like a product engineer. Fine. But one of the major problems I've seen or challenges I've seen is being part of that communication. It's being part of that communication. So then architectural review, they should be part of that. They should be part of design review and be able to check in, at intervals. Then the other thing is automate everything. So secure at scale, automation, learn Python, automation, GitHub action, CI/CD pipeline, policy as code. All those things should be learned by a product security engineer. Build publicly, massive career accelerator. Write blogs, publish GitHubs, tools, speak at OWASP chapters, contribute to open source, create threat models publicly. Yes, that is one thing I learned the hard way. So please learn in public, do everything. Just make sure that whatever is going on, you are improving yourself, you are building, you are learning, and you are improving very fast. So become strong in one specialization. Generalists plateau. Choose eventually cloud security, app security, product security, AI security, supply chain security, mobile, everything. These are the options available for you to specialize. And like me, I've always been like, I love being a generalist, but sometimes you can get plateau. But we are in a world whereby you might not be given that opportunity, where people are looking for like a niche, a niche specialist and stuff like that. So sometimes it's better for you to specialize at one point or the other. But I don't have the authority to tell you at one point or the other. But even for people, maybe hiring managers or whatever, one thing I always say is that if people are building their career around a particular area, when there is a special need for somebody who can niche out an area, they are better off, because it's like, I have done all these things at some level, general level. Now you want me to concentrate my effort, on a particular niche, like maybe supply chain security. It will be better for somebody who has been in the trenches for a very long time to just say, okay, now I'll be doing a lot of things, but they want me to concentrate on this. So I believe that in our team, we can share that responsibility. We can say, okay, maybe somebody have an affinity, towards supply chain security. Somebody is more like detection. This is the guy who can correlate, who can, piece the stuff together and make sense of it. Then we can move that person to, okay, that is my own style of leadership. We can say, okay, can you talk to that person? Can you kind of hold this area, and build it up? And these are the expectations and stuff like that. So I believe that when you have multiple generalists in your product security team, if you need to build special niche, for each domains, you can begin to, if you're a very good leader who wants to grow your team, I think you'll be able to spot what people have been doing and look at the areas they've excelling, in this thing, and begin to move them to those areas and help them to grow into that area. So the fastest growing area in 2026 above or plus and recommended learning sequence is grow areas, highest feature value AI LLM security. Yeah, I find it very fascinating. And one of the things I've been doing is to build, some agents, some local LLM, doing some APIs myself, and begin to see how I can break them, how I can secure them. so that at the end of the day, it's not just, I don't just want to kind of slap some toolings and stuff like that. So I think it's a very interesting area. Software supply chain security, cloud native. Cloud, it will be always be a crown jewel. So identity security. If you are working with maybe companies that are identity based, like maybe Okta, SafePoint, and some other ones, these are very good, areas. Secure AI engineering, product security engineering, and what you have to learn, like I've said, is you can learn, OWASP top 10, threat modeling, secure coding, cloud security. For instance, there's a lot to learn. I have a video series on, explaining AWS security features. Like every AWS security feature, I kind of have like maybe 10 minutes video on each one of them to say, okay, this is what they are all about. It's just for you to just have an idea of what individual security tooling is. I think I'm working on some on Azure and GCP as well. So these cloud, Kubernetes, and leadership as well. So these are the areas you can grow into. These are the things you can learn to help you grow into that. So the next thing I want to talk about is core component of product security. So this is not just about people that are finding their career, or they are roadmapping their career into product security. It could also help product security team to kind of organize things around their functions, right? So one of the things is the foundation, and which I call responsibilities. So the first thing you have to okay, let me back up a bit. So under these core components of product security, we have secure software development lifecycle. And if you look at this, I've mentioned it before, as one of the major domains or component of another domain that's very, very important. So, and under that SSDLC, the responsibilities are security requirements, security gates, coding standard, release controls, and how do we manage vulnerabilities. These are the things you do under secure software development lifecycle. Now, what are the skills that are needed? You have to learn how to do integrate security into your SDLC. You have to learn risk analysis, policy as code, ability to write your policy, to encode your policy in a way that can be automated. Developers workflow. These are the things. So tools. What are the tools of trade here? You have GitHub advanced security, GitLab security, Jira, and Backstage, and some other ones. And then the second core component of product security is application security. This time around, this is where web security, API security, secure coding, threat modeling, and also vulnerability comes in. These are your responsibilities. And this is where your OWASP top 10 capability, your authentication systems, session management becomes very useful. Then here you can, tools of trade is Bobsuit, Zap, SemGrep, QKL, Checkmans, and stuff like that. So it's very important for you to understand these core components and the processes or the things you're expected to do, and the tools that you can use to achieve that. Then the other thing is the other core component is threat modeling. So identify abuse cases, analyze trust boundaries, design mitigations, review architectures. Then what are the frameworks that are useful here? We have the STRIDE, the PASTA or PISTA, the attack trees, the MITRE attack. These are the frameworks that you can use in achieving threat modeling. I always believe that threat modeling is good, but at the same time, the tools are very, very important. The frameworks are very, very important because they help you to streamline things very, very quickly. And for me, I always want to reverse it. I don't just I want to start from the framework, and work backward. So tools, we have OWASP Threat Dragon. That tool is an open source tool that is owned by OWASP Foundation. Microsoft Threat Modeling tools and Lucid Chart too are all good products there. Then we talk about the fourth component is cloud and infrastructure security. This is where you are responsible for IAM security, Kubernetes security, secret management, infrastructure as code, and runtime hardening. Then your AWS, your Azure and GCP, your Kubernetes, your Docker. Then when it comes to cloud security infrastructure, WIS for cloud security posture management, WIS, Prisma Cloud, Trivi, Farco, and some Terraform Scan are very, very good tool in there. So let me look at component 5 and 6, and that is DevSecOps. So here your responsibility is CI/CD security, pipeline security, automated scanning, policy enforcement, and security releases. So if you look at the tooling, you can see GitHub Action, Jenkins, HashiCorp Vault, OPA Gatekeeper, and Argo CI/CD. So I'm not trying to really, reel out tooling and this thing for you. I'm trying to put them into context that if you find your function, as, and your responsibility kind of align with what you have under DevSecOps, then this kind of help you to know that, okay, this is what I'm expected to do. This is how I'm expected to, the kind of maybe tooling I can start with. Then the other one is supply chain security. Like I mentioned in the past slides, it's this is where you do your providence, like signing and verification of your artifacts, third-party risk, like your third-party risk, building integrity, software bill of materials. This is a generation of machine readable, bill of materials that can be used in other systems. So then we have SIFT, we have SigStore, we have Depender Port, Sneak. All these toolings are very, very useful. Then core component 7 and 8, detection and monitoring. Like I said, this is where telemetry security comes in. Runtime detection, attack detection, threat hunting falls under these detection and monitoring engineering. So this is where you are able to use your SIEM product, your SIEM, your logging facility, your cloud telemetry, put them together to make sense of what are those vulnerabilities and maybe weaknesses within your software ecosystem. And so here you can use some things like tools like Splunk, Datadog, Elastic, CrowdStrike, and other toolings under these event and incident monitoring. So vulnerability management, it's another core component. These are more or less like career paths, and they are more or less like functions, or let me say pipelines within security functions, especially product security functions. So you can have a functions that, or maybe pipeline for your detection and monitoring. You can have another function, another pipeline for your vulnerability management. You can have a DevSecOps pipeline. You can have a secure SDLC pipeline. So this is not just like it's not just like a specialization that a product security person wants to focus on. This can also help security team to streamline their function and make sure that all these things can be translated into pipelines, depending on your environment. So vulnerability management is another one. So what do you do here? Is prioritization. You have a lot of vulnerabilities from your scanners, from your engagement and stuff like that. This is where you begin to look at how to prioritize what exactly do we want to make our needed effort towards. How do you categorize? How do you say, okay, this is what is critical, this is what is high, and this is what is maybe normal, all this kind of thing. Then risk scoring, it's something close to that. How do you score your risk? Something high? Is it something low? Is it something that we care about, or something that can be best effort? So SLA tracking, service level agreements. This is what get down, at vulnerability management pipeline or pathway. So you used tooling like Tenable, like Quiz, and the Rapid7. Then the core component 9 and 10 is security architecture. So secure system design, architectural review, identity models, multi-tenant, isolation, encryption strategy. So this is where those decisions and trade-offs have been made. What kind of design pattern, secure system, architecture that is fit into your project. This is the component that take care of that. This is the pipeline you want to build for that. And what are the concepts you need to be very familiar with? Zero trust, defense in depth, secure by default, least privilege. The list goes on, but you have to be able to understand and identify all these concepts and the responsibilities, because when you know the responsibility, then you know the concept that it demands, then you'll be able to build system around it and make it something workable in your environment. So we have GRC here. This is systems governance and risk. So this is where you do risk acceptance, when you analyze, when you prioritize, and then you say, okay, we are going to accept this maybe based on this criteria and compliance mapping, metrics, reports, executive reports, and security maturity. So this is where your framework like NIST, like ISO, SOC 2, and CIS controls comes to play. So if you look at what we have done, what I've put together in these core components of product security is to lay out the major pipeline within product security domain or workflow, the pipeline that you can have, what can be done. And if you look at it, then any product security engineer can learn, based on that particular trajectory. And product security team too can use that as a baseline to start up their product security programs. So these are the stuffs. These are the things under the second part of the video that I call the foundation when it comes to product security. And for this, thank you for joining me, and see you in the next video.